In these questions, we have an integral between two limits. So it's called definite integrals when we have an integral between two limits. We're going to integrate it like normal, and then we're going to substitute in the two limits and take them away. So we've got 3 root x, that's the same as 3x to the power of a half. I'm going to integrate it, and then substitute in 9, substitute in 4, and take them away. So to integrate, add 1 to the power, and divide by the new power. 3 divided by 1.5 is 2. I'm not going to plus c. If I did plus c, when I take them away, the c would just disappear anyway. So I've got 2x to the power of 3 over 2, and I put these square brackets around it, and I've put the two limits on the outside. Now I'm going to substitute in 9, substitute in 4, and put a minus between them. So it's going to be 2 times 9 to the power of 3 over 2. Take away 2 times 4 to the power of 3 over 2. And then you could just type this into the calculator. Actually, the calculator will answer this question for us as well. But let's work it out. So 9 square rooted is 3. 3 cubed is 27. 2 27s are 54. Square root 4 is 2. 2 cubed is 8. 2 8s are 16. So I've got 54. Take away 16, which will be 38. So in these questions, when we're putting in the two limits, we get a number out as the answer. In indefinite integration, we get a function out as the answer. Here's one for you to try. Give it a go. So we're integrating 3x squared. So add 1 to the power, divide by the new power. So it's just x cubed. I'm going to put a square bracket and the two limits. Then I'm going to substitute in the two limits and take them away. So it's going to be 5 cubed, take away 2 cubed. That's 125. Take away 8, which is 117. Evaluate. So the integral of x squared plus 5x minus 2 with respect to x, and it's between 3 and 1 this time. So we're going to integrate like we usually do. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And then we're going to do square brackets and put the 3 and the 1 outside the square brackets. There are limits. Then we substitute in. So it's 1/3 times 3 cubed plus 5 over 2 times 3 squared minus 2 times 3. Take away. I'm going to struggle to fit this all in. 1/3 times 1 cubed plus 5 over 2 times 1 squared minus 2 1s. I might need to use a calculator this time. So I will just type this into the calculator. 1/3 times 3 cubed plus 5 over 2 times 3 squared minus 2 3s minus 1/3 times 1 cubed plus 5 over 2 times 1 squared minus 2, and I've got 74 over 3. I'm going to check my answer. So I'm going to press this button here, and it's going to bring up the integration sign with respect to x, And then we can write our function in. So using the x, so alpha x squared plus 5 alpha x minus 2. And then the limits between 1 and 3, 74 over 3. So the calculator will work this out for us. One for you to try. See if you can give it a go. See if you can do it without a calculator, and you can check your answer on the calculator. So firstly, we want to simplify it. So divide both terms by x. So 2x squared plus 3x. Now we integrate. So we add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And then the limits are 2 and 0. So substitute them in. We've got 2/3 times 2 cubed plus 3 over 2 times 2 squared. Take away 2/3 times 0 cubed and 3 over 2 times 0 squared, which will both be 0. So we've got 2/3 times 8, which is 16/3, plus 3 over 2 times 4, which is 6. 16/3 plus 6, so 16/3 plus 18/3 are going to be 34/3. And then on the calculator, so we've got 2x cubed plus 3x squared over x between 0 and 2. Error. Error. So let's change it to 3x and 2x squared. And we get 34 over 3. Given that a is a constant, and the integral of ax plus 4 with respect to x between 3 and 2 is a squared, find the possible values of a. So here's a question where we can't use the calculator because we've got an unknown in the question. So we're going to have to work it out without using the calculator. So we're going to integrate ax squared, so add 1 to the power, divide by the new power. 4 will become 4x, and that is between 3 and 2, and it equals a squared. So we'll substitute in the 3, substitute in the 2, and take them away. So a over 2 times 3 squared plus 4 3's minus a over 2 times 2 squared plus 4 2's equals a squared. So a over 2 times 9, we can write as 9 over 2a plus 12 minus, I'm going to keep the bracket for now, a over 2 times 4 is 2a, and that's plus 8, and that equals a squared. I'll get rid of the bracket now, so 9 over 2a plus 12, so I'm taking away both the terms inside the bracket, so minus 2a minus 8 equals a squared. So I've got 9 over 2, take away 2, so that's 5 over 2, 5 over 2a, 12 take away 8 is 4, and that equals a squared. So I've got a squared minus 5 over 2a minus 4, moving everything over to the right side, equals 0. And I'll use the calculator to solve the quadratic. So polynomial degree 2, I've got 1a squared minus 5 over 2 a's minus 4. So I've got 5 plus square root 89 over 4 and 5 minus square root 89 over 4. So a equals 5 plus or minus square root 89, and it's all over 4. One for you to try. Give it a go. So again, a is a constant, and we've got the integral between 9 and 0 of square root x plus a with respect to x is 9a squared. Find the possible values of a. So we've got x to the power of a half plus a. That's what we're starting with. So we're going to integrate. So let's add 1 to the power, divide by the new power. A becomes ax, and it's between 9 and 0. Let's substitute in the 9 and the 0. So 9 to the power of 3 over 2. So square root 9 is 3. 3 cubed is 27. And then 2/3 of 27, probably use a calculator for this. 2/3 of 27 is 18. Ax, 9a, minus 0 equals 9a squared. So I've got 18 plus 9a equals 9a squared. I can divide through by 9. So 2 plus a equals a squared. Make it equal to 0. So a squared minus a minus 2 equals 0. And I can factorize. It's 2 and 1. So a plus 1 and a minus 2. So a can be -1 or +2.